Hi everyone, welcome to this session in the afternoon. I hope you're enjoying yourself at the conference. It's awesome to see a packed room, well, at least half of a room because the light is really bright when you're up on stage here. But we're going to talk about application security, which is not really a surprise, I think, at NDC security, but we're going to talk about why things are maybe a bit harder than they should be for developers, and hopefully we can learn some lessons along the way of how we as a community, as a people of security champions, security engineers, or just developers concerned about security can do a better job in building secure applications. I know the title is not that great, like AppSec is too hard. There's like a nuance with the question mark and the exclamation mark. When I was building this talk, I've been brewing on this for a while, actually, when I was out for walks at home, because what else do you do when you're stuck at home? And a more interesting title would have been that the road to AppSec hell is paved with good intentions. That's like a much more dramatic theme, and maybe there goes some like really heavy metal song good with that title and something like that. And I like the drama of the title maybe, but it doesn't really click. And once I finished the talk, I realized that it doesn't really make sense to call this AppSec hell where we're going, because we're going to talk about good intentions, absolutely. We're going to talk about how people, engineers, developers, security people try to do the right thing, and eventually what they try doesn't seem to work out that well. But that's not really AppSec hell, right? AppSec hell to me is companies that don't even care about security, that don't try, that don't give a crap about building secure software. They're just like, yeah, whatever, security is not important. That would be AppSec hell. So the good intentions part, sure, that applies. The hell part, not as much. The picture was cool though. This is actually a real place on earth called the Gate to Hell. It's somewhere in Turkmenistan, if you know where that is. And it's something that's from the 70s. You should look up the story. It's pretty insane. They were drilling for gas there and something went wrong. And somebody had the genius idea, what do you do if gas is escaping? Like, let's set it on fire. That should solve it, right? And this thing has been burning since the 70s. And it's still burning today. So it's kind of applicable to some AppSec issues, even though things are getting better, as Jim covered in the keynote this morning. All right, before we dive into two concrete topics, let me tell you a word about myself. I'm Philippe De Ryck. I'm from Belgium, and I run my own company called Pragmatic Web Security. And every word in that sentence is important. Pragmatic web security, as in I help developers come up with pragmatic solutions based on what they want to achieve with the resources they have to build more secure software. And I do that through mainly do training, like developer training, conference workshops. I just completed a 2-day workshop on API security here, to in-house training and so on and so on. And that's essentially what I spend my time on. Usually on complex topics, API security, OAuth, OpenID Connect. If Steiner's talk from before lunch did not make any sense to you, then maybe I can help you out understanding what OAuth actually does. All right, enough about me. Let's talk about JSON Web Tokens. JSON Web Tokens, or JWTs, that's a good source for some, well, misery and pain usually, but also some really practical use cases. So what's a JWT? A JWT is a way to represent claims securely. That's a JSON Web Token. So the thing on the left, actually this is a debugging tool, JWT.io, but the thing on the left is what we call a JWT. It's a 3-part string, header, payload, signature, and it's base64 encoded. Well, each part individually is base64 encoded. And we use that to represent a bunch of claims, and that signature part, the blue part at the bottom, is what we use to ensure that we can protect the integrity. For example, an OAuth access token is often a JSON Web Token, which means that the authorization server issues it, signs it, and whoever receives that token, consumes that token, they can verify that signature to make sure that those claims haven't been changed. That's the mechanism that we want to use there. And we often use that for authorization purposes. So if you want to call an API with an OAuth access token, that's going to be a JSON Web Token. Many people build custom solutions with JSON Web Tokens as well. It's just a way to represent that data. The spec says like, hey, you can encode it like this, you can use it like, well, not use it, you can do these things with that, and that's how we sign the JWT, and here's a bunch of different options. All right, that's the context here. As you can imagine, something we use for authorization purposes, very sensitive purposes. If something goes wrong there, the consequences are kind of dire, and that's exactly what happened with Apache Pulsar somewhere last year, if I'm not mistaken. Yes, 2021. They had a vulnerability in their application which allowed an attacker to craft an arbitrary JWT, which would then in turn allow them to take over any account in the system. And it's as simple as I can create, if I'm the attacker, I can create a JWT that says like, oh yeah, I am Philippe and I'm an admin, and send it to the system, and the system will say, yeah, good enough for me. Welcome admin, and you can do whatever you want. That's essentially the gist of the vulnerability. And when I read a story like that, I'm always interested, of course, to use that as a case in presentations or trainings. And this is from the Daily Speak, a really good source for security news. And it's these articles are typically very detailed, like a lot of details and context and so on. So awesome, read that. And there's a link to a pull request. A link to a pull request that says, like, here's the patch to fix this vulnerability. So I'm like, oh yeah, awesome. Let's take a look at what went wrong here. What was the vulnerability? And here's the relevant screenshot from that pull request. The code in red is the bad one, the one that's removed, the vulnerable code, and the code in green on the right is the good one. And we use this, well, this is what was going on. And I looked at that and I was like, that's kind of weird. I don't really see much difference between the green and the red part. Yeah, sure, they're using different APIs a bit, but in the end, they're both setting a signing key and they're parsing the job and taking the claims out and making some security decisions with that. So what's going on here? That's kind of weird. And when something that's interesting to me doesn't make sense, I need to dig deeper. That's my PhD background kicking in. And I'm like, what's going on? And I wrote a little code example in Java, and I tried this out. So I built this parser builder, set a signing key for a job, build it, and then auto-completed that parse function. And you get 6 options. And I'm like, all right. I'm very familiar with JSON Web Tokens. I'm kind of supposed to be the expert on that. And I looked at that, and I'm like, I have no idea which one I should use. Well, I kind of know because the first one is the bad one, according to the pull request, and the third one is probably the good one, but I'm like, why? What's the difference? So yeah, that's interesting. We actually used this example in the workshop yesterday, and people was like, yeah, we have no idea. We have no idea what's going on. So it's a Java library. This is a library in Java to handle JSON Web Tokens. It's provided by an open source contributor, and if it's Java, there's typically Javadoc. So let's look up the documentation. Well, I couldn't find any. There's no Javadoc, whatever, about this library. That's like, well, it's open source, right? So the mantra is you can read the code. That's good enough. So let's go to the code. And in the code, there's actually documentation. So it does exist. It's just not rendered or hosted online. So that's already good. So we can read the documentation. And this documentation, you don't have to read everything here, but this explains what this parse function is all about. And I read that, and I was like, And we used this in the workshop yesterday, and I asked the whole room, 28 people, where does it say that this function is insecure? And everybody was looking at that, and like 5 minutes later, everyone was like, we don't know. So I kind of put them out of their misery, because otherwise it would have taken a while to find this. But it never says anything about, hey, watch out, this is really insecure if you use this for verifying JSON Web Tokens. It doesn't. There's a hint, though. If you look at the middle, there's this throws signature exception. That's the key part here. And it says, like, if a signature is found and it's invalid, we can throw a signature exception. Like, yeah, that makes sense. If the signature doesn't match, like, yeah, you should throw that. And the key word here is if a signature is found, which implies that if one is not found, that it doesn't maybe check the signature at all and just returns the claims like that is. I mean, that was obvious, right? Come on. So as a developer, I mean, no way you can get that out of that. And what does that mean? What's the vulnerability here? Well, the vulnerability is that an attacker can craft a very special JSON Web Token where the algorithm, the signing algorithm, is set to none, which is a legal JOT. If you look at the spec, it says like, oh yeah, if ELG is none, that means it's a token without a signature. So there's no integrity protection, but yeah, you can do that. So the attacker can craft a token like this, set ELG to none, include arbitrary claims in the payload, the purple part, and send it to Apache Pulsar. And Apache Pulsar is like, oh, I have a signing key, I'm going to verify the signature. Oh, there's no signature. Oh, in that case, we're good. Here are the claims, done, valid JSON Web Token, and that was your vulnerability. The token with ELG none looks like this. You have the header, the payload, and then nothing behind the dots. And that's the vulnerability that was present in that system, and that was the mistake that happened by the developer of Apache Pulsar. But yeah, it's probably a one-off, right? I mean, one developer makes a mistake, let's not create a big drama out of that. I mean, come on. Everybody has a bad Monday or Wednesday or whatever. Well, actually, this vulnerability is quite common. You may have guessed that. This is a really common problem in applications handling JSON Web Tokens. In fact, attackers know about that, pen testers know about that, and it's so common that there's a plugin for Burp, a very popular pen testing tool, to handle JSON Web Tokens, and that plugin has built-in support for the ELG none attack. As in, they know that you can change the algorithm to none, modify some claims, and send it back to the system, and it will, well, if it's vulnerable, it will accept that token without any issues. That's what this means in practice. This vulnerability exists in other places as well. Here's an example from a year earlier. The Out0 APIs, an identity provider, kind of very sensitive APIs. They handled Out0 tokens on incoming API requests. And this is maybe even worse because they knew about this problem, because their API code had a check, if ELG equals none, reject the token. Which is like, okay, that's maybe a bit of a solution. Could have done a bit more. But that checked for ELG none in lowercase. So when the attacker was like, ooh, but what if I provide none with uppercase letters? That doesn't match that string because it's a string equals, not a case-insensitive check, and they were able to bypass that restriction and exploit, well, it was a white hat hacker, so no exploitation, just a report, and they allowed that to be fixed in the API. JSON Web Tokens, always good for some fun. Some people, when they came up with JSON Web Tokens, some people warned about like, yeah, this spec is not the most secure spec, we think it's a bad idea. And they went ahead with it anyway, and those people have a grudge against JSON Web Tokens ever since. Maybe for good reason, but I'll leave that in the middle. Actually, they hate JSON Web Tokens so much that one of them built a website, how many days since the elgnonvuln.com. And they keep a counter of how long ago a new vulnerability was announced. And this is an old screenshot, it's not a recent one. There's another case on there right now. But it's an old screenshot to show you that this happens again and again, because I'm pretty sure that the UK NHS COVID-19 contact tracing app was not built as legacy code. It's a new application built from scratch in 2021 containing this exact vulnerability, which we've been warning about since 2015. Which kind of forces me to ask, what the hell are we doing here as a security community? How is it so hard for something like this to get fixed in practice? 7 years later, we still have this exact vulnerability. And it's going to keep going on longer and longer. Let me give you a first takeaway here. The first takeaway, I promised you some lessons, so let's try to add them in between of the depressing stories. And the lesson here is include common pitfalls in your test scenarios. Whenever you learn about something weird, or if you think of something weird yourself, write that in one of your tests. If you have an application accepting JOTs, I expect to see a whole battery of tests that give it invalid JOTs, like ELG none, invalid algorithms, invalid signatures, parsing errors, whatever, and you have to ensure that all of these get handled gracefully. Not with a 200 OK, but with some form of, maybe I should not accept that JSON Web Token. That's a very important case here. And ELG none should definitely be in your test suite so that you can be the one catching that issue, not an attacker trying to attack your application. That's takeaway number one. All right. The title was AppSec is too hard. Case in point. But this is not the only problem with JSON Web Tokens. I wish it was. That would be fairly straightforward to fix. But it takes a lot more to handle JSON Web Tokens securely. So what does it take to do that correctly? Well, first of all, you have to choose between a signature scheme, because JOTs support something symmetric with a shared secret called an HMAC, or they support a digital signature. Which one do you use? Well, I'm kind of giving you a hint here. The green is the suggestion. HMACs are very useless when it comes to JOTs, especially in a distributed scenario, so you want to use digital signatures, signed with a private key, verified with a public key. Awesome. That wasn't too hard, right? So we can figure that one out. Which signing algorithm do you use if you want to use digital signatures? There's like a whole bunch of algorithms supported by the spec, with very meaningful names like RS256 and PS256. It's like, oh yeah, I don't know. Well, I do know. PS256 is a good recommendation. Why? Well, there's a whole bunch of details behind it, and it's a pragmatic trade-off between library support and security and so on and so on. And that one is a good trade-off, as in it's widely supported, it's very straightforward to use, very easy to implement, and it's better than RS256, which is considered to be the standard or most commonly used. Next steps, well, if you handle a JOT, you have to verify the signature correctly, kind of important. You have to verify that the JOT is valid. And you do that by checking the signature, not accepting an ELK token. That's something we talked about before. And you have to check other things like the timestamp. JOTs have timestamps. Key claims are an NBF claim, not before, as in the JOT only becomes valid at this point in time, and an EXP, it expires at that point in time. You have to verify that, because you do not want to accept expired tokens or tokens that aren't valid yet. There's another bunch of reserved claims, all three-letter claims for fun and pleasure. There's the ISS claim, which is the issuer, and the AUD claim, which is the audience. You want to verify both. Like, is this JOT coming from someone I trust? Like, do I want to accept tokens from this entity? And is it intended for me? If I'm an API and the audience is like, oh no, send it to that guy, then I shouldn't be accepting that JSON Web Token. So all of these things is what you have to do as a developer. And it's not because the slide is full that the list is done. There's actually more here. Next step, we have to ensure that we support some form of key rotation, because we use a key to verify the signature on the JOT, but that key can change at any point in time for security reasons typically. So we have to support that. So that means you have to use a bunch of claims or an out-of-band key discovery mechanism to get the right keys and to maybe able to update them when necessary. All effort on your end. And then there's a couple of best practices that are more recent, like you should have an explicit type in that JSON Web Token as well. Like a token has a purpose, let's include that purpose in the type claim in the header, so it's very clear that that's what the token is supposed to do. That helps avoid token confusion attacks in practice. So all of this, and a bunch more that I haven't talked about here, is what we ask from a developer. And my question to you is that realistic? Is it realistic to ask all of this from a developer which has like 10,000 other things to do and has the same list of requirements for other topics and for performance and accessibility and this and that and that? I don't think it is. It requires a lot of expertise in JSON Web Tokens to be able to do this securely. And if you have to do that over and over again in every application where you handle JOTs, that's not going to work very well. And maybe you figured it out, but your colleague hasn't. And if you write it once and your colleague writes it once, there's going to be one vulnerable version. Or maybe two, who knows? Well, I don't know, but maybe it might be possible. So what's the recommendation here? What am I going towards? I'm going to recommend that you encapsulate behavior like this. There's no reasonable need for exposing all of these details to a developer. If you're using this as access tokens for APIs, why don't we verify this with a security library? Why don't we provide our developers as security champions, as a security team, or as concerned co-developers? Why don't we provide them or ourselves with a library that says, here's how you handle that token. You throw it in there, and it will verify all of these things for you without you having to worry about any of the details, and it will give you the claims or an exception, or whatever works in your language. Silent error is always good. But that way, that's the takeaway here, that way we encapsulate this security behavior in libraries. We absolve the developers of that responsibility of having to know all of these details, having to make sure that all of these details are correct, and having to do it over and over again. And that's a very, very important pattern. And that's the only way we're ever going to solve this thing. Otherwise, there's always going to be someone who misunderstands which parse function to use, which is very easy to happen, as you have seen, and which can cause massive vulnerabilities in our applications. So the next step is, we have a library. How do we get developers to use that library? Well, that's a very good question. So how do you scale this up? How do you allow people across an organization to use that? And the best reference I have for that is this story from Netflix. It's an article from Netflix on how they integrate security into their process. And it's actually a really interesting read. It's a pretty long article, but I recommend you take the 11 minutes that Medium says it takes you to read that, to actually read that article. And the gist of it goes like this. Netflix, when they did security, the security team had like this massive checklist for security. Like hundreds and hundreds of things a team was supposed to do to build a secure application on Netflix. And they went to the teams, the development teams, and said like, hey, here's your security checklist. Can you go through this, please? Can you make sure that your application is secure? And they said like, oh yeah, sure. When we find some time, we'll do that. And 3 months later, the security team went back like, dear developers, where's that security checklist? Have you done it? Like, yeah, we'll get to that. Give us some time. We don't have time right now. And it didn't work very well. It was like a very painful process and resulted in a lot of issues in real-world applications. So they took a hard look at their approach and said, like, why are we bothering developers with having to do security? It doesn't really make any sense. And they call this the paved road, as in they want to make it as easy as possible for development teams to do things securely. And the way to do that, the way to get that done, is by helping them do their regular jobs plus security. And what they did is they built a tool that bootstraps a new project within the Netflix ecosystem with a few commands. So instead of spending half a day of setting up repos and DNS and this and that, they just said like, okay, here's the command, you run this, and we will do that all for you. We will create the DNS records, we will set up the properties, we will provide you a code skeleton that integrates with single sign-on and all of this stuff. And it does a whole bunch of security things under the hood, sets everything up, and developers basically went from half a day setup to 10 minutes. And they didn't even have to go to the security checklist because that was integrated from the beginning in that whole process. And that made everybody's lives easier, and all of a sudden security adoption was very straightforward and very easy to follow up on. And that's a good way to make this happen in your company as well. Help developers do their job in a better and more straightforward way by including security as well. If you tell them like, hey man, all that JOT stuff, you can forget about that. Just use this library, they're probably gonna be like, oh, thank you, awesome, bam, done. That's how it works. And you can reuse that library across applications as well. Like if you have 15 applications that all handle that same type of access token coming from that same authorization server, guess what? The same library can handle that for all 15 applications. That's a huge gain that you have there. And there's a secondary benefit here as well. Because you encapsulate this behavior, your system becomes more flexible. You're able to change your system when you want to change it. Want to change the signature scheme on a JOT or the algorithm? Sure. Update the part where you issue it and the part where you verify it in that shared library, and you're done. You want to change the token format? You can do that because you have encapsulated that, extracted them away, extracted that out of the application, and put that in an encapsulated library, making your system more flexible. And this reminded me, creating this slide reminded me of my software engineering classes at university where you learn these patterns. It's like, yeah, encapsulation and abstraction are important. And as a student, you're like, okay, if you say so. And then afterwards, you see this in practice and you're like, oh yeah, this actually makes a lot of sense. Now I can change this whenever I need and nobody else has to worry about that and it doesn't break any part of the application. So yeah, a whole bunch of lessons we can learn about AppSec. Enough about JSON Web Tokens. That's where we're gonna wrap it up. Let's talk about React. React, front-end applications, completely different topic. No API security, no authorization tokens, no. We're building front-ends now in a browser, which is always, again, good fun, especially because of problems like cross-site scripting. So, what's cross-site scripting? Here's an example of a very simple React application. Purely for demonstration purposes. We have a bit of an HTML template where we add some data provided by a user. This is a restaurant review application, or at least a small part of it, where we have a review with a title and the contents of that review. And if one of our users provides us a review, the user can be a tad malicious and they can provide us a review that contains evil code. And in the example you see here, we have some HTML embedded in the review, and the red part is the dangerous part. It's an image source none, which means the browser will see that image tag, try to load it, doesn't find image none.png, gives an error, and instead it executes that on-error event handler, which is an alert, which is very non-dangerous. But if that code executes, if the alert should pop up by accident or by mistake, that's a vulnerability, then the attacker can do anything else as well. The moment the attacker can execute JavaScript code, your application is compromised. Because that means that I, as a malicious user, can upload that review into the system, and every one of you looking for restaurants in Oslo tonight will get that review, and that code executes in your browser. So I provide the code, submit it, and it executes in all your browsers when you visit the application. And that gives me control over your application. I can now start creating reviews in your name, change the looks of the application, steal your passwords, and so on, and so on. Pretty dangerous, and basically means game over for the front-end application. So, what happens if we put this into that template using React? Well, it looks like this. Awesome. There's no code execution. That's good. That's because React is protecting you by default. So React is not stupid here. React knows exactly what you're doing when you write code as you see at the top. React is like, oh, you're gonna put data in an HTML page? That's dangerous, right? That results in cross-site scripting. So I'm going to escape these characters. I'm going to translate the open tag for an HTML element into the %LT semicolon, which is the representation of that character, so the browser doesn't see that as code. And React does that by default for all these data bindings. Awesome. And if the React developers are like, yes, I chose the right framework, the other ones do that as well. Angular does it, and Ember does it, and Vue does it, and Svelte, all the decent frameworks do that by default. That's standard behavior. They understand these templates, and they know how to secure that by default. Awesome. Good. Finally, secure by default. We're getting there. And then you end up in the use case where you want to render pretty content. You want the user to allow something like CK editor data, so they enter some rich text format in an editor, and behind the scenes it's going to submit HTML to your server or your API, and you want to render that HTML in the browser. Well, if you want to render this with React and you use the curly braces, it's going to encode all of these characters. It's going to look like crap. It's really, your users are not going to be very happy, and neither will you, and your boss won't be very happy, and so on and so on. So how do you render this as HTML? Well, rendering untrusted data as HTML, that's dangerous. That's DOM-based cross-site scripting, which has been introduced like a long time ago, as Jim covered in his keynote this morning. So how do you do that in React? How do you output this in React? Well, there's a property you can use for that called dangerously set inner HTML. How do you use that one? Well, you can kind of guess. You call dangerously set inner HTML, and you provided an object, and in that object you provide __HTML as a property with the review data. And if you have the data at the bottom and the code on top, and you insert this, you see this rendered HTML. You can see that I'm a very skilled designer as well, by the way, and you get the alert. You have a massive vulnerability in your application. Yeah, of course. I mean, it says dangerously set inner HTML. What did you expect? That was going to be safe? No, of course not. This is dangerous for a reason, and React says like, okay, inner HTML is dangerous, so you know what? We're going to make you very aware of that by marking this as dangerous. So don't use it the wrong way, because that's dangerous. You're supposed to sanitize that review. What you're supposed to do is you're supposed to call a sanitizer. DOM Purify is your sanitizer of choice. That's a solid library working in JavaScript applications. So you call DOM Purify, you tell it like, I have a piece of dirty HTML, that review, I want you to make it safe to include in a page. And DOM Purify is going to parse that HTML, it's going to walk the tree, and keeps everything that it knows is safe. It has a list of safe elements and attributes. And everything that it doesn't know, like an on error, it's like, blah, on error, out. And what you end up with is safe HTML that you can include in the page. And that's what you're supposed to do when you want to output stuff into the page. If you put this into the page, you get that. The bold tag is there, the image tag is there, the link is there, except the on error part, that is gone. So the code execution vulnerability has disappeared. This is the correct way of outputting HTML in React applications. All right. So what's the takeaway here? What did we gain by doing that? Well, by doing this, we basically prevent accidental misuse of a very, very dangerous feature. That's what this is all about. Why? Well, for two reasons. The less common reason is autocomplete in IDEs. If you just autocomplete stuff and you drop it in there, then you may have no idea what you're doing. So if you autocomplete something that's called dangerously set inner HTML, that should trigger a bell. That's reason number one. More common is because if you copy paste this from Stack Overflow and it doesn't say dangerous, then you have no idea what you're doing, which is primary reason to make this property called dangerously set inner HTML. So if you copy paste this and you look at it and you're like, I should probably look into that. That's essentially what we're doing here. All right, awesome. So does that wrap up React security? Well, unfortunately not. So I've been teaching this for a while now. I've been teaching this for a couple of years, and the more I teach this, the less convinced I become that this is actually a good way of doing things. And that's why I want to talk about this in a bit more depth, because what we're doing here is we're basically warning developers like, hey, watch out, this is dangerous. Like, watch out, there's a cliff here. If you fall down, you'll probably die. And they're like, yeah, go ahead anyway. We warned you, so if you fall, it's your own problem. And that's about it. We don't really care about what happens after that. And what happens in practice is that this works as intended. I mean, if you slip on that trail, you will die. And if you make a mistake in your React application, you create an intentional cross-site scripting vulnerability. So that process kind of strikes me as wrong. And if you put yourself in the perspective of a developer, you find that dangerously set inner HTML property somewhere, and you're trying to do a good job. I honestly believe that most developers want to build secure applications. So what do? You look up what that means, right? Why is this called dangerous? What should I do instead? And you're going to find the React documentation, the official docs. And the official docs are going to say like, dangerously set inner HTML? Yeah, you have to watch out because this can cause cross-site scripting attacks. And then the second sentence is, so to set it anyway, you have to pass this object like this so we can remind you that it's dangerous. It literally says in the last line to remind yourself that this is dangerous. And this screenshot is the entire documentation on this property. That's it. So we're basically expecting developers to understand what this means. I can promise you, if you've never heard of cross-site scripting, this thing means nothing to you. It's like, okay then. You have to look up how to fix it correctly as a developer. You have to trust that the developer finds the right source because there's no solution here. There's just a wrong example. Then you have to trust that they use that approach in the right way and that they apply it correctly in their application on every single use of dangerously set inner HTML. That's kind of the thoughts and prayers equivalent of application security, right? It's like hoping that things work out, and in practice, it doesn't. Here's an example from Signal Messenger, one of the most secure messaging apps in the landscape of messengers, and their desktop application was built in React. React in Electron, and you can see again, it's a very nice pull request. GitHub pull requests are awesome for screenshots. And on the left, you can see the bad code example, dangerously set inner HTML, like whoopsie. And on the right, they have transformed that into a secure way of rendering that. And the case in point here is that it's good to mark something dangerous, but it's not enough. It doesn't stop abuse of that feature. It stops accidental misuse of that feature. It just helps a little bit to inform people that have no idea what it does, that this might be somewhat dangerous. It doesn't magically enable developers to use that feature securely. And that last, second to last word is kind of important here, feature. The use of dangerously set inner HTML is a feature, which means if you want to output HTML in React applications, there is no, well, I'm not going to tell you the other ways because they're even worse, but there's no by design way to output HTML except for using dangerously set inner HTML. So if you're building an application and you want to render HTML, even if you want to get it right, even if you want to make it secure, you still have to use dangerously set inner HTML. What does that mean in practice? In practice, it means your code base is going to be littered with calls to a dangerous API. There's going to be dozens of places with dangerously set inner HTML in your code base. And that's a very, very bad idea because it stops you from doing a bunch of other things for security. Let's say that you're a responsible developer and you're like, okay, we're going to build more secure React apps, so we're going to start scanning our React apps for bad code. You can use a tool like SEMGraph or a linting tool. There's linting rules for this as well. And SEMGraph is going to run a React rule base, just like this. And if it does, it's going to come back and says like, I found a potential issue. Now, SEMGraph is not the smartest tool. It's very fast and efficient, but not very smart. So it just looks for dangerous API calls, dangerous patterns, but it doesn't know if this is actually dangerous or not. It's not a full-on static analysis tool. It's just a pattern matching tool, basically, hence SEMGraph. It finds, on line 62, dangerously set inner HTML. It says like, I know that that is dangerous because I copy-pasted the warning from the React documentation, to be honest here. But it says like, yeah, you have to watch out because if you misuse this feature, you have a cross-site scripting vulnerability. And now as a developer, you can look at this and be like, but I'm using DOM Purify, like Philippe said, so this is safe, right? Yes, it is. This is safe. Good. The bottom line kind of shows that this is a demo app. 3 files in a React app, that means nothing. And 1 finding is also nothing. In reality, it's going to be 45 files and 10 findings. Or 4,500 files and God knows how many findings. More like it. Yes, thank you. What do you do then? Like, oh, there's 100 findings. Okay, good. I'm going to scroll through every one of them to see if all of them are safe. You can do that once. Are you going to do that again next week? Probably not. So this basically means by littering your code base with this dangerously set inner HTML, you lose the ability to scan for misuses of that API, because these tools are not built for that purpose. Linting rules wouldn't be better, by the way, and static analysis tools don't support React very well. And that leaves us with unhygienic code. It leaves us with code full of dangerous patterns that may or may not be safe, depending on how you use them. And that's not very good. This pattern is a really bad anti-pattern. What can we do better? Well, what if we would provide proper semantics? What if we would be able to explain in code that this is actually safe by using something like this? Safe HTML, what do you want to create? Oh, a paragraph, and this should be the content of that element. If you look at the code at the bottom, this is clear to you what that does. Even if you have never heard of any React code, you can be like, safe HTML, like, oh yeah, this is probably good. This is a clean way of doing that. And that component is not very complicated. I mean, the code on top is how we use it, and at the bottom, there's the React component that actually does that. And what does it do? It creates an element and sets the inner HTML using dangerously set inner HTML and unpurified, the proper way of doing that. And your code is a lot cleaner on top, and it looks a lot better, semantically correct. And that brings us back to this one. We covered this before. Encapsulate security behavior in libraries to make developers' life easier. Instead of teaching developers like, use dump purify everywhere, hopefully the right way, we can now teach them like, hey, just use that safe HTML component that we're using in our organization and you're covered. We'll take care of that for you. Want to output HTML? Safe HTML. Want to output HTML with some specific styling? Safe HTML with styling. Done. Easy, straightforward. And you get something in addition to that. Because of encapsulating that behavior, we now get the ability again to scan our application, because if we run semgrep, instead of 10 findings, we have 1 finding. Look at where it is in the safe HTML.js component on line 6, because that's the only place where we ever use dangerously set inner HTML. And you can get rid of that warning by going to that component and marking that one as, please ignore this. That's the only way you can do that, by the way. Never do that for crappy code, only do it for code you have manually verified that is secure, that you're 100% sure. Then you can tell semgrep, let's just keep this between us. You don't have to report about that. That's our little secret. And when you do that, you get 0 findings. Awesome. An empty list of stuff to do. Everybody likes that, right? It's been a long time since I got there, but it's not the empty list that matters. What matters is that you can set up the scanning tool on your code base. And it's not going to find anything until you hire an intern next month. And the intern writes their first React feature, and they find some crap code example somewhere on the internet, dangerously set inner HTML, blah, blah, bam. You run your semgrep tool in your build pipeline, in your commit hook in GitHub, and semgrep is going to be like, hold on, no, 1 findings, or 5, depends on what they're writing. We don't do that. This is a dangerous API call. And you can customize the message even and say like, hey, in this organization, we use a safe HTML component which will handle this for you, and that's the way we do things. And you gain the ability, again, to scan your code base for potentially dangerous patterns, allowing you to catch them the moment they're introduced and stop them from ever existing in your production application. And that's a really, really important takeaway. We're basically using code hygiene for security success, which is like the most catchy takeaway ever, right? But this really helps because we encapsulate dangerous behavior, we hide it away, we avoid littering our code base with potentially insecure patterns so that we can actually catch the true insecure patterns when they are introduced, so they can't hide in the noise anymore. And applying this to other security concepts, I could keep going, but I'm not going to do that. Apply this to other security concepts, that's essentially the only way we're ever going to scale security across large applications and organizations, because no tool will ever be able to deal with all of these things automatically. But by helping tools, by encapsulating this behavior, we can easily help tools gain more control, help tools, and essentially win at scale for application security. So, is application security too hard? Well, yeah, I kind of think it is. We can't expect developers to figure all of this out because it's not just this one thing, it's all of these other things. And developers don't have the time to learn or to follow like 3 days of security courses to figure out how to put values safely in React. Well, some of them do because I have them in my classes, luckily. But that's never gonna work very well. And if you follow the workshop at the conference here, you know that at the end of the workshop, you have like a whole ton of things to look at. Like, oh yeah, keep this in mind, keep that in mind. And that's never gonna work because it's only gonna grow and grow and grow. So we have to do something else. We've been doing this for 25, 30 years and it doesn't work. It no longer scales at all. There's too many guidelines, too many details, too many nuances that we have to take away from developers. The question part, the answer to the question is, it doesn't have to be. Yes, AppSec is hard. Fortunately, Jim gave a keynote this morning to tell us how AppSec has gotten a lot better. That's good. And I think we can push that even further. I think we can push it further by learning from these good intentions. All of the things I talked about here were not malicious acts. The React developers, there was not a conspiracy among the people building React like, yeah, we're going to screw them over by calling this dangerous and having them use it everywhere. No, they tried their best to mark this as dangerous, and it kind of doesn't work in practice. That's the takeaway here. Good intentions. AppSec hell, not so much, but the road, at least to where we're going, is paved with good intentions. So what we have to aim for is the right level of abstraction. We have to look for that abstraction that helps developers get their job done, support them in their job, and focus on proper and usable security, preferably with the right semantics. And I believe if we can do that, we can make things significantly better towards the future. And that's my message here for the conference. And with that, I want to thank you for being here. If you have any questions, I'll be happy to answer them right now. We have someone with a mic, so let's make them run around a bit if there are questions. Healthy workout. Yeah, no rush with the picture. Apparently the last slide stays on until the next speaker arrives, so you'll have plenty of time to do that. All right, anything? All AppSec topics are fair game, so. Yes, there's questions over here.
I can just talk loud.
Yeah, sure, that's good. I'll repeat the question for the live streaming audience.
On your very first example with the parse, dot parse, did the third option actually validate the signature correctly?
Yes, so the question was, with the JOT example of parse and parse claims JWS, does the parse claims JWS actually work more secure? Yes, I actually verified that. So I went beyond the auto-completion suggestions and I tried them out. And the parse indeed does accept an ALG token. Parse claims JWS requires JWS is the abbreviation for JSON Web Signature. So it requires a signature. It doesn't move forward without signature. Would have been better if there was a function like parse without verifying signature and parse securely. That would have been a bit more meaningful in this case, but yeah. Fair question. Anybody else? Yeah, just shout.
How do you expect developers to be aware of security issues in files when you're calling them safe HTML?
Okay, so the question is, if you call something safe HTML, how should developers be aware of security issues? Well, that's the whole thing. They shouldn't. If you use it in that file.
Because I don't know with everybody else here, but I'm never 100% sure that my code is secure. So even if I make a file and call it safe HTML.
Okay, yeah. So the question is, how can you ensure that the library you're using or the component you're using is actually safe instead of containing vulnerabilities? Well, that's a fair question. That's where security people come in. So in an organization of reasonable size, you typically have developers and you have security champions embedded in the development teams, and you have a security team which are dedicated AppSec experts. And they will be able to tell you that this is the right way. They'll help you develop that component, that library, and they tell you this is the right way of doing things. or you can just copy paste the code from my slides and use that. No need for having a security team. But yeah, you'll have to rely on somebody to provide you with the correct way to build that secure component, and from that point on, you can use that. So as a developer, and don't necessarily recommend that every developer now starts building their own security components, but the recommendation is more likely that the security team provides that, or a few people with more security expertise do provide that, or you hire a consultant to provide it for you, and the moment you have that, you can start using it.
You mean people that never make mistakes?
Well, in that case, we can just burn the whole castle down, right? there's always going to be mistakes. That's the inherent nature. Find good people. That's my advice. And yeah, of course, validate and test and guarantee. But trust me, even Dump Purify, that sanitizer, has mistakes. But when there's a mistake, they are quick to catch it, they're quick to fix it, and everybody can update that. You'll have to account for mistakes, will always be there. Building perfect software is impossible, so I would suggest you find a different profession, but finding something where no mistakes ever happen is also not going to go well. I'm a chef, for example, as well. I went to evening school to cooking school, and in the kitchen, that's a very good example. There's always mistakes, like all the time something goes wrong. You just have to account for that and pivot on the fly and deal with that. And the same with software security. There's always going to be mistakes. There's always going to be that bad morning where you screw it up, just like with everything, and you'll have to deal with it anyway. So set up processes to deal with that. That would be my advice. And if you don't trust your own code, then ask someone to review it. That would be the best way to ensure it's safe. Yeah.
Wouldn't the best way be to ask the people who create React to instead of having a company internal safe HTML, to ask the people at React and Angular and Microsoft and everywhere that would be the
Okay.
place to fix it?
Hold on. Why are you mentioning Angular? Angular? This is a very interesting question. So the React people, React has this idea of being a component library. They're not claiming to be a framework. They're a component library. Like, hey, we allow you to build components, and you can use them to build applications. And sanitization to React is out of scope for what they're doing. They don't feel the need to offer sanitization. Angular is a framework, much more heavyweight, so all the React developers hate it because Angular has like, it's my way or the highway, basically. But if Angular's way is something you can find yourself in, and Angular is a very good framework, which I'm a fan of. And Angular does sanitization by default. Angular said like, yeah, screw this. We're not gonna allow developers to do this themselves because we've seen this in the old version, Angular 1.x. They're gonna screw it up. We have plenty of Stack Overflow examples that actually make something safe by just saying like, yeah, whatever. And that's a very bad thing. So in Angular 2+, they said like, screw it. Nobody can touch this again. We're gonna do this by default. If you assign something as HTML into the page, we will sanitize it for you. And you can't even turn it off. You can't touch that mechanism. And that's a much better approach, in my opinion, because you get this out of the box. You don't have to write your own safe HTML component. You just use the things the Angular way, and you're good. But even that is not enough. And that's very interesting because I do Angular security workshops, and I explain this whole cross-site scripting thing. I talk for an hour about cross-site scripting, and then the conclusion is like, yeah, Angular does all of this out of the box. And people are like, why the hell are you talking about it then? It's like, yeah, because here's the way you can bypass that. There's a function called bypass security trust HTML, which takes some HTML and says like, yeah, this is safe, don't touch it. And what happens when I explain that is people use the GitHub search feature, like search in my organization for bypass security trust HTML, and they come back to me like an hour later, like, yeah, crap, we had a vulnerability that uses exactly that function. Because they had a scenario that has to do a little bit, that had to enable behavior that the sanitizer doesn't allow, but they need it for their customers. And the only way to sidestep the sanitizer is by fully disabling it for that piece of data, which they did. And functionally it works, but it allows any arbitrary piece of code as well. So why don't we do it more by default? Well, because React doesn't think it's necessary, and even if you do it, there's still ways to mess it up. So in Angular, the example I give there, instead of using this bypass security, I tell people, why don't you build, it's called a pipe in Angular, where you can pass things through, like a sanitize with style. And that tells you exactly what it does without having to use bypass security trust HTML all over your code. Same principle, just a little less common in Angular than in React. The other frameworks are more like React though. So Ember and Vue, I know about those, though they don't do sanitization by default either. So you're responsible for that yourself as well. All right, anything else? Going once, going twice. All right, thank you very much for being here. Enjoy the rest of the conference. If you want to learn about API security, by the way, I'm back here tomorrow morning with another talk. So come see what that's about and enjoy the conference and the party tonight.